Okay, let's go ahead and get started. Hi, everybody. I'm glad there's a pretty good turnout here first thing in the morning. My name's Darren Jones, and I work at Attendees. And in spite of this being a RISC-V conference, I'm not really going to talk about RISC-V. I'm going to talk about SoCs, and yeah, I'm going to talk about processors. But frankly, everything that I'm saying here kind of applies to any IP when you're trying to build a complex SoC. I used to work at large companies and small companies before I joined Attendees. I was building large SoCs, so I've sort of lived the pain of that a lot. So I only have 10 minutes here this morning, so I'm just going to touch on a few key things. Hopefully, you guys find it useful. Maybe the first thing, and I think you guys probably know this, to build an SoC, it's really, really difficult. You kind of can't believe what the EDA guys say, you know, buy our tool suite and it's just push button. It's not really quite push button. And part of it is because you really do have to know what you need to do, right? So know what your goals are. What are your metrics? Are you running, if you're an AI company, you're probably running matrix multiplies. You might be doing softmax. You want to accelerate those things. If you're doing automotive, your goal is I need ASIL B or maybe I need ASIL D. I don't know, but you'd be surprised at the number of people who kind of have a general idea, but they really don't know exactly what they need to hit in order to be successful. And part of that is, what are you doing to differentiate? What's your secret sauce, okay? And it's really important to know that. As well as what's your schedule. I get a lot of customers who come in and they have a general idea, or they have something that's ludicrously unrealistic. Like, I'm gonna license the IP this month, and in 3 months, I'm gonna be ready to tape out. It takes a long time to build an SoC. There's a reason why you see in the news that these things cost 30, 50, 100, $200 million to develop. It really is difficult. It takes time, and it does take expertise. So the real first thing here is your architecture of the chip. And this, of course, has to fit within the larger system if you're building a system, but you have to decide what it is that you're going to do in hardware. And then what it is that you're also going to do in software. Frankly, if you can live with it in software, you should want to do the problem in software because it's much more programmable when things change. Frankly, to do a software release is, I won't say free. I'm a hardware guy, so I think all software is easy. But it's much easier to release new software. It doesn't cost you $10 million like it does when you need to release a new version of hardware. So you kind of want to make sure that whatever you're doing in hardware is what's required to do in hardware, and then do everything else in software. This might push you into a higher performance processor so that you can do more things in software. That's probably a pretty good trade. Once you've sort of figured that out, and I'll talk a little bit about some of the tools that you need to do that in modeling your SoC, then you go into hardware design. You have to decide about your IP, and I'm going to talk about that. And of course, there's also software development. So I'm not telling you guys anything you don't already know, but I want to I'm focused on purpose and the front end here. The more you can think about it up front, the less problems you're going to have later. The enemy of schedules is change later. If you're remodeling your house, those change orders are expensive. If you're building a chip, the change orders are even more expensive and more detrimental to the overall schedule. So I have a slide here about processor IP selection. Frankly, it applies not just to processors. It applies to any IP. These are general guidelines. You have to think about, you know, what's going to be your performance and power. Think about, how do I want to interface? Is it almost everything today is AMBA something, AHB, AXI. Do I need coherence? Do I need to have CHI? And then what other pieces of my large SoC? Is it Arcturus? Is it Baia? Am I going to build my own NoC? All of these things are considerations. The second bullet about customization. So this is going towards your secret sauce. You want to make sure that if it's a RISC-V processor, and here we are at RISC-V Summit, so hopefully it is a RISC-V processor, which extensions do you need? I think some people think of the RISC-V extensions as sort of fragmenting the RISC-V ecosystem. I don't actually see it that way at all. I see it as you get just the processing you need without anything less and without anything more. And those extensions are there on purpose to enable you to do that. So you want to make sure that you have what you need. Do I need hardware crypto acceleration or not? Things like that. Most of the standard stuff, single precision float, double precision float, hardware multiplier, MMU or not, you get to decide that. These are pretty standard options in the IP world. But the customization comes sort of the idea of RISC-V is what I said before, just exactly the processing you need. But when you're licensing IP from a company like Attendees, we want to enable you to add your custom operations, your custom instructions. So how can you do that? Does your IP provider enable you to do that? At Attendees, we want you guys to do that. And so we do provide a sandboxed way, we call it ACE, Attendees custom extensions, to enable you to add something as simple as your own instruction, or you could add your own coprocessor. So we have a number of machine learning customers who have used this capability to basically get an off-the-shelf, fully compliant RISC-V CPU attached to their secret sauce, which is the world's fastest matrix multiplier. They've all got the world's fastest matrix multiplier, and they're all doing something a little bit different. So they needed a way to program their thingy and still have Linux off-the-shelf RISC-V compatibility. Sometimes we have customers who, once they find out about, oh, you can customize it this way, then they start to think, maybe I can do a different secret sauce or more secret sauce in a way that differentiates me from the rest of the guys. So that's that last bullet there. You do want to make sure that you're getting all the proper IP deliverables. Attendees has been around for 20 years, always as a pure play soft IP company. So we've started off knowing that all of our products, from the older ones to the brand new ones, are always going to be delivered as IP. And that comes with a lot of different deliverables. Of course, there's RTL, but is there a test bench? Are there tests? What documentation exists? And is it readable? Does it make sense? Is all the information there? You want to have your IP exact models. You also want to have models of the core itself, including both instruction accurate, very fast models, as well as cycle accurate models, so you can see if your workload is going to meet the performance targets. I go back to the original thing that I said, which is you need to start off with modeling of your SoC architecture and make sure that you're going to be able to get there. It's really difficult to know that until you have hardware, so you do need to have those kind of models available early on. Attendees also provides System C. I would propose that any IP provider today needs to provide System C models. That's a very popular way of modeling SoC, larger SoCs. And then, of course, don't forget about product support. You are going to call us. Make sure that you have that support. It's either email or phone. They're responsive, and don't forget to check out your IP providers on that point. And finally, maybe another thing that's easy to forget, you also do want to have a way of gauging the quality. And I'm not going to lie to you guys, as part of an evaluation for some of these complex IP, not just processors, think PCIe controllers, interconnects, it's difficult to tell. You can't just look at Verilog and say, that looks like good quality. Although your vendor should allow you to look at the Verilog and you can see, does that look like good, clean code or not? You can ask them questions. Are you lint clean? Which lint? Which rules? How clean? Can I see a report? You can also actually talk to your colleagues. If you're at a large company, somebody else probably uses that vendor, or you probably have friends from around the industry. Check it out. You can do that. Word of mouth still matters. Relationships still matter. Vendors should be equally responsive to all of their customers. And then processor IP selection. You do want to think about both. Whoops, I think I'm repeating myself here. Sorry. Software considerations. Software is important, and when we're talking about RISC-V, there's areas where RISC-V is very well, the RISC-V software ecosystem is very well developed. So things like operating systems, compilers, debuggers, that's actually pretty much equivalent in the RISC-V world to what you can get from ARM these days. If you're coming from an ARM legacy system or some other processor, even if it's another RISC-V processor, technically speaking, RISC-V processors are compatible. But even if you go from this generation RISC-V to tomorrow's generation RISC-V, potentially with higher performance, you still do need to do some code porting for that code that's very low level next to the iron code. So application code is pretty easy. Frankly, you recompile, very straightforward. Firmware might need to go through that kind of layer of optimization for hardware. Third-party code is an area you have to focus on. Do you rely on something that you don't control the source for? In which case, go to that vendor, see do they have a RISC-V port or not. There's also a lot of software libraries. I mentioned a couple important ones here. If you use digital signal processing, the usual way that's accessed by software is through a DSP library. Same for neural nets. And then don't forget about debug. I think RISC-V is very strong in debug. There's a lot of options there. You want to make sure that that is going to work and is approved with your vendor. Collaborating is also very important, and these are some tips that I like to give. It's kind of, when you read them, it's kind of obvious, but a lot of people, when they're evaluating, don't think about this. I would say engage very early with your key IP providers, especially your processor IP. You want to make sure that you haven't decided your architecture too soon. You want to engage with them, make sure that that processor, whatever capabilities you need, be it bus connectivity or performance, multi-issue, vector, how wide is the vector, you want to make sure you've got that, because early on you still have some flexibility. So if you can engage early, the better it is. IP providers have a lot of deliverables. Make sure you use those. If there's a test bench, run it. Too many customers don't run it, or they think it's not necessary. The test bench that Attendees provides, make sure that when you integrate your RAMs into our processor, that you've connected up all the wires properly. Reads happen, writes happen, byte writes happen, all of that stuff. So all of that test will help you succeed. The documents, you know, I think the support people always say, read the document, right? Maybe not in those exact words, but it is important, and they are there. The sooner you get used to it, the sooner you can internalize the knowledge that you need. Use those models that I mentioned. You have your cycle accurate, you have your fast models. Use those as well, and definitely call us. If you have a support question, call your IP vendor. We want to hear about it. We don't want you spending a week out in the weeds. Spend a day trying to figure it out. If you can't figure it out, call your vendor, right? Build that relationship, because it'll help you over time. That's about it. I probably went a little bit over. Thank you very much. I'm leaving my name, and my email is really easy to remember, just 2 letters, DJ. So if I'm happy to take a few questions right now, and Xiaoling, my colleague, has some sort of prizes for anybody who's brave enough to ask a question. I think you get some sort of a dongle thing for your computer. Any questions? Very good question. So her question is, when using that ACE to customize, and her example was she might have a Matmul engine. How do you move data in and out of that? So the answer is we would still use the RISC-V loads and stores to move data, so that we've simplified the custom operation so that it looks like any other RISC-V operation. It's going to be accessing registers from the register file and writing a result back to the register file. So you're loading and storing to and from the register file. On our vector core, the AX45 and now the AX46, you can also add custom vector operations. So that, in that case, you'd be reading and writing from the vector register file using the vector loads and stores that are part of RISC-V. You can also use ACE to move data from outside of the world into the register file or into your compute engine. So using our version, using ACE, you can actually define custom ports in and out of the CPU, thus making it, if it's important to feed data in, not from the main cached subsystem, you can also do that. It's extremely flexible. Very good question. So the question is, if I have a custom instruction, how does that get into the system C model, or is it in the system C model? And the answer is yes. With the Andes ACE system, you actually tell ACE you have a golden model, which is written in C or system C, and then you have your Verilog. Our ACE system will take your golden model and integrate it into our RISC-V system C model for the whole CPU. We also add that custom instruction into the GCC, so now you have it available as an intrinsic, so you can actually code your custom instruction and run it on the system C model. We encapsulate all of that so that it's all taken care of. It just works. Yes, that's right. It's all automated. So the question is, Andes has our method of verification, our verification methods, and you as an SoC customer have your own verification methods and your own verification standards. Those are different. And so, yeah, you're right. They are, every IP provider has a different level. So I have a couple of answers. One which is a little bit flippant, and the flippant one is you have to, if you don't trust your IP provider, I think you have to get to a place where you trust your IP provider. You're really, when you're licensing IP, you're not paying for the Verilog. Frankly, you can go out there and find free versions of RISC-V processors. What you're paying for is the verification. That is really what you're paying for. And Andes, part of the reason I'm at Andes is that I believe Andes has very high quality products. That's why I say go back to, check with your colleagues, find out, does this company deliver high quality product? Is it have bugs? Does it not have bugs? Do they support you? Those kinds of questions. I think during the evaluation phase, you can also ask your vendor, please give me an overview of your verification. Most vendors are not going to give you their verification because that's kind of, that's the proprietary thing. I used to work at MIPS a long time ago, and MIPS would happily share almost everything. The one thing that never left the building was the verification suite, the full verification suite. The limited verification suite went to customers as part of the deliverables. Very good question. So the question is, do any customers implement our cores on FPGA first, and do we support them? And the answer is absolutely yes. And yes, we certainly do support them. And in fact, we have standard FPGA boards that we are already compiling to, and we have our board farm in the cloud that we can give customers access to for those pre-compiled versions. It's really expensive to tape out a chip. Depending on who you talk to, just the tape out cost alone can be 10 million or more. And so if you're spending that kind of money plus all of your engineering salaries, you're going to do emulation and FPGA. Otherwise, somebody thinks they're saving money. They're not, because they're adding risk to a multi-million-dollar program. For large SoCs, I would never skip the FPGA or the emulator piece of it, even though it's exorbitantly expensive, the emulator. FPGAs are much better. Anybody else? There's one more. I'll take one more and then I think I have to go.
So when I was interning at my previous company, I got to understand that whenever we deal with the IP provider, so it's always the interconnection which causes the bugs most of the times instead of the IP. Like the IP is working really properly, but it's always the interconnection which causes bugs. So what are your views on that, and how can IP provider company try to reduce that area?
So his question is, in his previous experience, the bugs were never inside of the IP. They were always in the interconnect or the connections to the interconnect. So as a processor guy, that makes me feel good. But the reality is bugs, no matter where they are, cause bad silicon. So at Attendees, what we do is we actually partner with both Arcturus and Baya to make sure that our interconnect, our AXI and CHI interfaces work with those interconnects that are out there. I actually don't. I think both of those interconnect providers are very high quality. I think you can't go wrong with either of them. I would be a little surprised if they had bugs inside their thing. You can have bugs where you've connected things improperly, and in that case, one of the tests that Attendees provides and tests that you SoC developers can develop is, I want to see all of the different AXI transactions going in and out. That's actually not that difficult, even to cover corner case. So I would recommend that as well. Yeah. All right. If there's any other questions, I'm going to be here for a little bit, and I'm also going to be at the Attendees booth, which is right on the other side of that wall there. So please come and ask questions. And I do have some business cards here if anybody wants to contact me afterwards. Thank you very much, everybody.